YouTube is screwing me about. Ah, now it works. Right. So I'm doing it off the phone, but I'm keeping the charger plugged in because the it's got noise suppression on it. You'll notice something different. Oh, I took my Concentric 8s off the, both of them are here. I've not wound any new coils yet, but I thought, I was having to think about this, and I thought, well, I don't want to change too many things all at once because I won't know what makes things better. Because let's face it, if I wound 4 new coils for this device, a generator, right, and I also put new coils on with the new magnet rings, I would think, well, which made it better? Was it the magnet rings or was it the coils? So I thought, hang on a minute, I need to slow down here. Let's just leave the existing coils on for now, stick the new T6s in with the double magnets and see what we get. And that's what I'm doing. So these are the C8s. I took these out because these have got the little magnets in the middle there and in that dip, you know, that little valley there you can see. And then they've got the big magnets on the outside. So anyway, this is the C8s that I was using previously. I took them out and I put my brand new freshly made C6s in there, as you can see, and I had a bit of an issue though because the coupling or the ferrite rings, if you look at the cups are supposed to hold the bobbins, but they're supposed to be a lot closer to the magnets as well. But at 4 volts on the up there on the supercapacitors, at 4 volts I am now seeing 50 milliamps coming in, right? Remember before I wasn't seeing anything up there. Oh, I don't know if you can see actually. Can I zoom in on here? Can I zoom in? No, I can't. Anyway, the thing is, look at that, 70 milliamps. 70 milliamps. Previously, I was under 50. I was around 45, 50. We're actually at 70 milliamps. And that's the voltage on the AC coil as it climbs. Don't forget, I'm charging supercapacitors as well. So if I actually take the supercapacitors off, because I'm actually charging those up at the same time right now. So if I disconnect the supercapacitor, right, that's disconnected. Look at that, 95 milliamps. Right, and there's another set of supercapacitors still connected. What happens if I disconnect those? Oh, that one must have been the one I disconnected already. I was looking. Oops, I can't move the phone very far because I've got the lead connected because my battery is shot. Right, well that's with that supercapacitor. Where's that going? That one's connected to that one. Oh, I see. I've disconnected all the supercapacitors. Anyway, so we're actually pushing out 95 milliamps. Right. Let me get the light angle a bit better. That's a bit better. That's the AC voltage on this coil. It's just that coil at this bottom end, the weak one. It's the weak one, so we're measuring the voltage across that coil, AC. And I got my oscilloscope connected, and yeah, that's a lot better. And we're actually about 80 milliamps on the input. Well, it's up and down. It's jumping up and down, but the input current hasn't changed really. I think I was about that before. Oh shit, is this still live? I don't know what's going on here. It says I am. I must be. Yeah, I can see myself on the I can see myself on the monitor, so I must be. Silly me. Duh. Anyway, the oscilloscope waveforms are much more sine wavy because I've got the capacitors across the AC to smooth it out. So it's let's see. I haven't got much leeway because it's a long wire. I've got the charge leading. So that's what we're seeing on the waveform and the frequency. We're now running at 2.6 kilohertz. So I had to adjust it again slightly. I'm pick to pick on that blue one is 18 volts, and RMS 6.8 because we're under load, don't forget. And I'm not actually measuring the main output coil, by the way. The scope's not connected to the main output coils. The main output coil is, oh, actually I am on one of the output coils. This output coil, which is that one, that's going to the bridge rectifier, and the other output coil is that one, and this wire goes all the way around here and around here, and it goes to that coil at the bottom right, this one here. And that coil's not got the scope lead on it. That's probably producing a higher voltage. But what I did find, oops, I don't want everything to fall over. What I did find, obviously it's making more noise because I've got less. I wrapped some rubber around, some amalgamated rubber around the magnet rings to help to reduce the amount of resonant noise that we're getting from it, but it's still quite loud actually. But it is annoying, and I hope that the phone noise cancellation is doing its bit to try to keep the noise down. But yeah, this is encouraging. I mean, I have effectively doubled my output without actually increasing my input. I won't say exactly doubled, but I'd say what, maybe 90% better than it was. Is it 90% or is it? Yeah, anyway, my brain's gone to mush. I can't think straight at the moment. But I was sat here pondering and waiting for these things to dry because I acetone treated them, and you saw them, and I think I showed you pictures of it. Maybe did I? I can't remember now. Anyway, there's one of the. Here's one of the. Magnet rings that I made, which I actually got the hole in the middle a little bit too small on this one. This is one of the rings I made, and I acetone treated it, and you can see how nice that come out. The only thing wrong with this is the hole was a bit too tight. I decided to go a bit tighter. I was trying to adjust the size on the inside to make them easier to, if I remember on the previous video I was doing the I had some issues with getting the cores to go in. They were too tight, and I had to grind them down a bit. So I actually made the new one a little bit larger, so it was a bit easier. I started to grind it though, but yeah. So I sort of just filmed this because I was a little bit beside myself, because I'm thinking, oh, well, that's better. Yeah, a lot better. So we're on the right track, but these coils are not perfect still, because these actuator coils do need to be a lot thinner. They do need to be a lot smaller because of that frequency. They're not tuned for this frequency. For 2.6 kilohertz, those coils really are not ideally wound for that frequency. They're probably more suited to something like 1 kilohertz or lower even than that. So I need to do some new ones, and I need to make 4 actuator coils. There's 2 at this end, there's 2 underneath. You can't see, really, I don't know if I can show you. They're not hidden as much as they were, but you see there's 2 at the bottom. There's 1 at the bottom there, 1 at the bottom there, and then there's 1 at the top. And my theory about pulling more flux out of the concentric, pulling more flux out of the concentric is correct, my theory, because I speculated that because the way this is going, this is pulling flux out of here, of say North Pole, and this on this side is pulling flux out of here, say the South Pole. And obviously it travels up through the laminations around the corner, and same on this side, and they meet up in the middle. So we have a unity balance created between it pulling on this side, and they collide there in the middle. And we have this air gap situation of the with the laminations, with that little Oh, hang on a minute. I've got one I can show you. Oh, I'm going to unplug my phone from the charger just a minute because I want to show you the sheet of laminations and it's across the room. Just a minute. I hope it doesn't kill my battery too quick because it will do because the battery's had it. Right, here's a sheet of laminations. I took some of these pieces out. You can see the actually, I'm knocking them over. Let me take a sheet over there and plug the charger back in because it's dropping like a stone. The battery's had it. It's just dropped from 95 to 93% while I was talking without the thing charge plugged in. Let's just plug that back in again. Right. So these laminations, I had these laser cut about 4 years ago, 3 years ago. I lost track. Right, I'll just pull one out so you can see it. It's got a cutout. I need to put a bit of paper on the back so you can see a bit better. Oh, I want a blank piece. Right, so you can see it a lot better with a bit of white. So the magnet, the way it's working, oh, this phone's getting red hot now. The concentric magnets are arranged with the magnet on this back side here like that. So there's a magnet, right? So what you're doing, what's happening, it says there's a south pole on that face, and this is lamination is a shunt, and if you have a north pole on this end, it's going to subtract and suck out which is the coil. The coil is sucking out, that's, oops, it flipped around on me, that happens. So it sucks out that south pole in this direction, but on the alternate phase, when the phase is reverse, it sucks the south pole out on this direction on the other side. And same with the north magnets, you know, when on the north magnets, because some of these laminations are on south, some of them are on north. So because we've got sets, you see, as I was explaining. So by doing this, what happens is when you subtract south from here, this end becomes less polarized. So more north on the other laminations can travel in the opposite direction. So it assists the magnetic pole switching both the coils on both sides. These are actually very short because I cut them down. I cut these long legs off right up to this. Well, that little, you can just see the little bit sticking out. I said that, but there's these little bits sticking out here. I cut them right up to that edge across there because I originally designed these for a different project, and the coupling was too weak. It was very mild, but I knew then I was on the right track because it was doing the things I hoped it was doing, but it was just very, very weak. I was getting it was a ridiculous situation on those rotary systems. I was getting something like 10 milliamps, 5 milliamps output. It was pathetic, it really was, but it was not slowing the rotor down very much. It's actually speeded up on some situations, which is the kind of thing I'm seeing with this. In the electronic sense, it's drawing less current when it's under load. So it's the same basic thing that's going on, it's just in a solid state situation instead of a mechanical one. I'm going to leave that in the sheet. I don't want to pull it out right now because these are the only ones I've got left of these, and when it got there was 36 of them. I used 3 in each slot, and I used 36 of these laminations in these 2 magnet drums, which is a lot. So I haven't got many left. I've got probably, I don't know, probably 15, 20, I don't know, in this sheet. It's going a bit rusty. And these are another set of these are similar. These laminations are similar, but they've got a thicker backbone on there. The bridge it's got, I call it the bridge. It's a thicker bridge on here than it is on these. These are very thin. So these have got a very thin bridge. Put the paper behind it so you can see. So those, I've got a shadow now. Those have got a thin bridge on the back, and these have got a much thicker bridge, as you can see. So slightly different. I made some variations so I could try different things out, you see. I'm going to leave them in there for now. I want to take them out. I've got a problem storing them, you see. Anyway, I thought I'd do that and show you what's going on. We're definitely making headway. And look, we're still at 90 milliamps. Look, on the output. That's very encouraging. And I'm actually seeing 60 milliamps on my. Oh, let's just unplug the charger again. A minute. Well, I'll go across here so you can see. I keep forgetting I can unplug the charger. We're definitely seeing a reading now. If you remember when I was doing this test before, we weren't even getting a flipping reading on there. So I'm actually getting an extra 60 milliamps from what I did. So yeah, that's definitely a positive sign considering I'm not drawing any more power. Put the charger back in again. Right. So yeah, I thought I'd give you a news update, what's going on, and I'm happy about that. Yeah, that's good news. That's something to celebrate, I suppose, because it means that things are working out a bit more positively. Obviously, when I short the load out, the input current doesn't change. It just, well, I haven't done that for a while, but oh, guess what else? I got a whole. Oh, I'm gonna have to unplug charger again. I got a whole batch of new leads. Yay! Cheap Chinese leads, I know. These are all brand new. I just got them, so I got a whole bunch of new leads, so that we're not going to run out of leads anytime soon. Because the other lot were, you know, they break, they go wrong, things happen to them. This plastic that they put on the leads shrinks after a while, and then it stops the clips from closing properly, and then you have to take the sleeve off. So what I've had to do is pull the sleeves off. It's when you're putting a lot of load through some of these leads, they actually start to get warm, and that's when it causes problems, if you know what I mean. Yeah. So yeah, we're at 5 volts on this little coil at the moment. It's still charging. It's going a lot faster. I'm a lot faster than it was before. So I'm out of breath now, talking too much. So anyway, oh, what's going on with this stupid Ubuntu sending me update software messages? Oh, no, rubbish. Flipping heck. Right, so I think I'll pause my virtual machine. It says average view time 16 minutes. Yeah, people don't seem to have the attention span that they used to do for watching YouTube or whatever. I don't know. I think I'll pause that because I can edit it later. Right, because I'm about to finish now anyway. So I love the virtual machine. It's so useful. I can just pause it and then go back to exactly where I was and check it later. It's obviously it's not gonna stop the stream though. It'll continue until I stop. So that's good news. What else is there on the agenda? Well, I've got to wind some new coils, obviously. I'm not sure if I've got enough wire, because I'm not sure exactly what gauge I'm going to use yet, but I've got to have a think about that because I want to find the right resonant frequency. I want to get 2.6 kilohertz resonant frequency on these. So what I might do is wind one coil and then do some checks to check the resonance frequency to see if I can optimize one, and if I get one right, then I can do all the others the same. I do have what's called a dip meter. I don't know if you know what a dip meter is. I've had this for many years. It's something you can use to tune a resonant circuit. Oh, let me see. I don't know if I can. Let me unplug the charger again. Let's see if I can grab it and show you what I mean. I think I showed it once before, but it's somewhere around here. I could use my dip. Oops, I don't want everything to fall on me, so I'm trying to be a little bit careful yet. Oops, right. this is a mapling tool. Just give me a minute. Right, a dip meter works with a tune circuit, whether it's powered or not powered. Ah, come on, bloody hell. The box is so old it doesn't want to open. Right, so what you do with the dip meter, for anyone that's new to electronics and you want to find out what a dip meter is, you've got sensitivity, you've got function, and you can generate a frequency, and you plug a coil in that's suitable for what you want. So there's these coils that go between, we've got the marking, there's markings on them, 41.5 to 4.3 megahertz. That coil's from megahertz. Obviously we don't want megahertz, we want something much lower than that. The trouble with most of these coils are all in megahertz, and I'm working with kilohertz. This is the lowest one I can find. Oh no, it's not actually. 6.8 to 18 megahertz. But the thinner the coil, the higher the frequency. So yeah, I've thought about using my dip meter, but it looks like I can't use it. Looks like I won't be able to use my dip meter, but yeah, I'm just going to have to do it the old-fashioned way. And with the oscilloscope and get a peak waveform. I can't see that writing on that one. That goes down to 4 megahertz. Yeah, I was thinking about using my dip meter, and I realised I can't because it won't go low enough. It's been a year since I last used this thing. I've still got loads of silica gel in this thing. Damn it. I suppose I could make a coil, but then it won't scale up on here. It's not gonna, there's not gonna be anything on the scale for kilohertz. That's the problem. Yeah, there's probably a modern equivalent I can use, something, but I thought I'd show you that just in case you were working in megahertz anyway. Right, what else is there? Not a lot, but I'm happy about that extra current I'm getting now. And we're at 90 milliamps at the moment. I've actually been tweaking this a bit, so yeah. Obviously, as I say, when the greater the load on this, the less current it uses. So let me see if I can short this bridge rectifier out again like we did previously. Exactly the same thing. Oh, look at that. Look at it drop down to 60. Look at that. 60 milliamps it dropped down to. That's with this shorted. I put a knife across there, so the output dropped to 0. Take it off. Going straight back up to 88. Look. Back up to 90. So when I short the output circuit, it's not getting much current off that one. Oh, hang on, isn't this? Oh, I haven't got this one wired up. This other coil, I haven't got it wired up. Bloody hell! I just realised something. Yeah, I had all these coils wired up previously. This one's not even wired up. And I'm getting 88 milliamps. Bloody hell! Yeah, this one's not wired up. Obviously, if I connect that one up as well, my output's going to go up even more. Let's get some new leads. Oh, my battery's down to 82%. Let's get a red lead and a green lead, a new one. I'm just... So there's one of them. I've got 2 brand new leads. Can't remember what I was connected to now when I was doing this last time, but I'm pretty sure it was. I'm just splitting them apart a bit so they don't touch. Let's connect that lead. Oh, they're slippery as well. These Chinese leads, they're slimy. What's going on? I'm knocking something. I'll clip onto that one. Right, so what was it connected to? It must have been this one that I've got the oscilloscope on. So I'm going to clip on to this channel. Right, we're at 88 at the moment. Let's clip onto this channel. There's the green. Where's my yellow one? Oh, my red one I want. There's the red one. Let's clip onto the other one. Let me get this on right. These things clips are slimy. They keep sliding. When you try to squeeze the damn clip open, it slides on you. Right, it's on. It's not bloody changed. Huh, that's interesting. Is this lead crap? Am I actually on there? And my phone's cooking. It's cooking with gas. Well, that's weird. I'm not seeing. I must be clipped onto a different coil before, because that coil is a low voltage coil. Let me see, which one was it clipped on before? Let's see, there's 1, 2, 3 clipped on. Oh, it must have been that one. Maybe it's just I haven't peaked it for that coil. That's strange. Oh, it might be because I've got too much capacitance across it as well. Let me just try clipping it on. Maybe it's because the oscilloscope's connected to that one. It goes up a little bit. It goes up to 0.5. If I take it off, it drops a bit. Look, it does go up. It changes slightly. It just changed slightly. I'm going to take my oscilloscope lead off. Ah, if I can. Right, let's try. Let's see if my oscilloscope was shorting it out or something. Right, 88.2. Let's clip it back on. No, that coil's not doing anything. That's weird. Oh well. Anyway, I'm going to end the stream because battery's at 79%. It's actually not doing too bad. Mind you, I have had the charge lead on it. Yeah, it probably wants peaking. The circuit probably wants peaking and tuning with all 3 coils connected. That's probably why. Yeah. Might as well put the oscilloscope back on now. It won't reach now. Oops, it's because I'm holding the phone. I can't lift this up and get it on the probe. I know what I'll do. Take that end off. Oh, that doesn't work. How do you do this without the thing on it? It won't work until you plug it in. Silly thing. My wire's too short. See if I can backhand it up. Oh, I can't do this. Thumb. Maybe I can do it like this. I'm trying to get my lead. Oh, it doesn't matter. I'll do it later. Anyway, that's it for now. Thought you find that interesting.